Okay, suppose you had this problem on a test. The integral of dx divided by x cubed plus x squared plus 1 plus x. Obviously, it's not going to be solved with the u/du type substitution. The integral in the numerator, there's just a 1 here, 1 times dx. That clearly is of lesser degree than the denominator. But we can't use partial fractions, or at least not yet, because the denominator isn't factored out into its prime factors. Well, let's see. This is x squared plus 1. We could factor an x term out of these two, and look, that would also give us an x squared plus 1. So let's see. We have this expression, x cubed plus x squared plus 1. And this is x cubed, not x squared. So factor an x out of here. We have x times x squared plus 1 plus x squared plus 1. Here we have x squared plus 1, and we have it here, so we can factor that out. That will equal x squared plus 1 times x plus just 1. So we can rewrite the integral dx divided by x plus 1 times x squared plus 1. There, once we have this factored out, now it's obvious we're all set for a partial fraction substitution. So let's see. We're going to have, let's rewrite it up here. This integral equals divided by x plus 1 times x squared plus 1. So this is going to be a quadratic factor. And let's see, to set this up for partial fractions, we have 1 over x plus 1 times x squared plus 1. And that will equal, this is a linear factor, so just have a constant over that. Plus, now, this is a quadratic term, that's to the first power, so now we're going to have b times x plus c divided by the quadratic term. And we explained this in our introduction video. Okay, so let's multiply across, and we're going to have 1 equals a times x squared plus 1 plus bx plus c being multiplied by x plus 1. And let's see, looking at like terms, we have x squared here, and we have an x squared here, so we'll have a plus b times x squared plus, here we have bx. If we multiply through, we'll have c times x here, so b plus c times x. And for constants, we have a, we multiply over here, we'll have c, so we'll have plus a plus c. And no x squareds on this side. A plus b equals 0. No x's on this side. B plus c equals 0. And one constant 1. So A plus C equals 1. Okay, if we go through those, and we'll see c equals 1/2. We go through the algebra here. B is minus 1/2. A becomes plus 1/2. So, going back to this step, we have 1 over x plus 1 times x squared plus 1 is equal to, a is 1/2, so we're going to have that. While we're doing this, we'll just rewrite the whole integral. We'll have the integral of dx divided by this will equal, a is 1/2, so that would be 1/2 the integral of dx over x plus 1. B is minus 1/2, so that will be minus 1/2 the integral of x over x squared plus 1. And c is equal to plus 1/2, so we'll have plus 1/2 the integral of dx divided by x squared plus 1. So we started off with this without too much problem. We could factor that out. We go through the partial fractions then, and our integral falls right apart. Dx over x squared plus 1, hopefully you recognize this as inverse tangent of x. The differential of that is dx over x squared plus 1. And we'll have a 1/2 times that. If I say let u equal x plus 1, du is dx, that's du over u, so this would be 1/2 the natural log of x plus 1. And what about this one? Well, we forgot to write our dx. If u equals x squared plus 1, du would equal 2x. Let's look at this integral here. Should fall right apart for us. X dx divided by x squared plus 1. Call this u. One-half of du will equal x dx, which is what this is. Oops. We're looking at this integral here. We're saying let's call this u. 1/2 of du would equal x dx. So this integral here is 1/2 the integral of du over u, and we had minus 1/2 times that. So multiply this by minus 1/2, and that will equal minus 1/4 the natural log of u, which is this. So here we have this. From this integral we have this. And that should be our answer. We went through these pretty quickly, but really they're not complicated at all. Again, you should be able to recognize that the derivative of the inverse tangent of x is dx over x squared plus 1. So this is just the inverse tangent of x times 1/2. Call that u, that's going to be du, so this is going to be 1/2 the natural log. And again, we wrote it all out down here. This is going to be another du over u type deal. So really, that right there is the solution. If we wanted to, we could combine these here and do some manipulations with them. But this right here is certainly an acceptable answer. So let's see, this was equal to dx over x cubed plus x squared plus x plus 1. And clearly, if we had this integral here, it would not be obvious at all that this right here would be the solution to it. But we factored this out, used the method of partial fractions, and everything pretty much just falls right into place. Okay, come back and join us for another video, and we'll see if we can tackle a more complicated problem.